Welcome to our Network and System Security course at Tarleton State University. If you're new here, I'm glad you've joined us. In this video, we'll explore Module 11, Cloud and Virtualization Security. We'll cover different cloud types, public, private, hybrid, and community, along with key cloud architectures and models like IaaS, PaaS, and SaaS. We'll also dive into essential cloud security controls and the challenges of securing virtual environments. Understanding cloud and virtualization security is vital for advancing your career in IT and cybersecurity. As cloud solutions grow, so does the need for professionals who can keep them secure. Thanks for watching. If you find this helpful, please like, share, and subscribe. Your support helps us create more great content. Have questions or topics you want to see? Drop them in the comments below. Let's get started with Module 11. Let's jump into the essentials of Module 11, Cloud and Virtualization Security. First, we'll cover the different types of clouds. Public clouds like AWS and Azure are available to the public and offer scalability at a lower cost. Private clouds are exclusive to one organization, providing more control over data and security. Hybrid clouds mix public and private clouds, offering flexibility by sharing resources between both. Next, we'll explore cloud security controls, essential practices to protect data and infrastructure. Key controls include encryption, identity and access management, IAM, and network security measures. Finally, we'll touch on virtualization security. Virtualization lets you run multiple virtual machines on one physical machine, which is efficient but requires careful security measures to protect the hypervisor and manage access controls. Now, let's dive deeper into the types of clouds and their specific security implications. Cloud computing is a powerful model that allows for convenient, on-demand access to a shared pool of computing resources, such as servers, storage, and applications. This flexibility is what makes cloud computing so appealing for businesses and individuals alike. Organizations that provide these cloud services are known as cloud service providers. They manage the infrastructure and offer various services that can be scaled to meet the needs of their clients. One of the primary benefits of cloud computing is its cost savings, which are driven by several key factors. Elasticity and scalability. Resources can be quickly adjusted based on demand, ensuring you only use what you need. Pay per use. You only pay for the resources and services you actually use, avoiding upfront costs for hardware and software. On demand. Resources are available whenever you need them, providing flexibility and reducing the need for extensive planning. Resiliency. Cloud services are designed to be reliable, with built-in redundancy and failover capabilities to ensure continuous availability. These factors not only reduce costs but also make cloud computing a practical choice for modern organizations. Characteristics of cloud computing include on-demand self-service, where users can adjust computing resources like storage or processing power as needed, without requiring help from the service provider. This means you can scale up or down instantly based on your needs. Universal client support facilitates cloud services that can be accessed from virtually any network device, including desktops, laptops, smartphones, and tablets, making it highly versatile and accessible. Invisible resource pooling lets cloud providers pool together physical and virtual resources to serve multiple users. The location and management of these resources are handled by the provider, giving users minimal control over the physical aspects. Cloud also provides immediate elasticity, where resources can be quickly scaled up or down to match demand. This means you can handle increased workloads efficiently without over-provisioning. Metered services users to pay based on the amount of resources they use. This pay-as-you-go model ensures you only incur costs for what you actually consume. Let's dive into the different types of cloud deployment models you'll encounter. Public cloud. Imagine a cloud space that's available to anyone via the internet. It's managed by third-party providers and is great for flexibility and cost savings. Because it's open to everyone, you're sharing resources with other users, but it's super convenient and scalable. Community cloud. Think of this as a private club. It's only accessible to specific organizations that share similar concerns or goals. This type of cloud allows those organizations to collaborate and share resources while keeping things more secure than a public cloud. Private cloud. This is a cloud just for one organization. It can be hosted on-site or by a provider but is completely dedicated to that organization. It offers more control, customization, and security, making it a great option if you need to handle sensitive data. Hybrid cloud. This setup combines both public and private clouds. It's like having the best of both worlds, allowing you to use public cloud resources for less critical tasks while keeping sensitive operations in a private cloud. This flexibility helps balance cost, security, and performance. Understanding these cloud types will help you choose the right environment for your needs, whether you're looking for cost efficiency, control, or a mix of both. Here, you can see the various locations for computing resources, explaining where and how data processing occurs, from on-premises setups to cloud and edge environments. On-premises, computing resources are physically located within your organization's own facilities, like a data center or local network. Off-premises, these resources are managed and hosted by a third party, such as a remote backup facility. Fog. This computing places resources between the data source and the cloud, helping with local processing, like automated vehicles on an industrial floor. Edge. Data is processed at or near its source, such as an IoT device, reducing latency and improving efficiency. Cloud. Resources are provided remotely over the internet, like an AI processing engine, enabling scalable and powerful data handling. Understanding these locations helps in making informed decisions about infrastructure and security. Now that we've covered various types of cloud and computing resource locations, let's dive into some specific technologies that enhance cloud and virtualization security. Thin client. A thin client relies on resources from a central cloud server instead of a local hard drive. Transit gateway. In AWS, a transit gateway connects all virtual private clouds, VPCs, data centers, and remote offices into a single managed network. Serverless infrastructure. In a serverless setup, the cloud provider handles all capacity planning, installation, and management, making these tasks invisible to the user. Let's look at key cloud service models. Software as a service, SaaS. Here, you use the vendor's software applications hosted on their cloud infrastructure. Think of it as renting software applications like email or CRM tools directly from the cloud. Platform as a service, PaaS. This model allows you to build and run your own applications on the cloud. You have control over the apps you develop but rely on the cloud provider for the underlying platform. Infrastructure as a service, IaaS. With IaaS, you manage your own software, including operating systems and applications, but the cloud provider handles the hardware and infrastructure. Anything as a service, XaaS. This is a broad category encompassing various cloud-based subscription services, covering everything from software to platforms and infrastructure. Understanding these models helps you choose the right cloud solutions based on your needs and control level. Cloud management can be handled in two main ways, either by your organization itself or by partnering with a third-party management service provider. Services integration aims to create a seamless experience by integrating cloud services across the entire enterprise. This approach strives to remove barriers, allowing users to access and utilize cloud resources smoothly, no matter where they are or which cloud services they use. When managing cloud computing in-house, it's crucial to have clear written resource policies to guide operations. A managed service provider, MSP, offers ongoing support and administration for cloud resources, whether they are managed on-site, in the MSP's own data center, a third-party data center, or within a cloud environment. A managed security service provider, MSSP, specializes in cybersecurity, either assisting with or fully managing your organization's security defenses. Traditional application design, often called monolithic, involves developing the entire program as one single unit. To address this, we use a microservice architecture, breaking the application into smaller, specialized components. Each microservice manages its own database, generates its own logs, and handles user authentication through its APIs. This approach allows for more flexibility and easier management compared to monolithic design. Knowledge check. You have been given a project to manage the development of a new company app. You want to use a cloud model to facilitate the development and deployment. Which cloud model should you likely choose? SaaS, XaaS, IaaS, or PaaS? Answer: PaaS. Platform as a Service, PaaS, provides a software platform on which the enterprise or users can build their own applications and then host them on the PaaS provider's infrastructure. The software platform can be used as a development framework to build and debug the app and then deploy it. In a cloud computing environment, virtual security devices play a crucial role in protection. Cloud Firewall. This virtual software acts like a physical firewall, inspecting traffic coming in and out of the cloud to ensure security. Secure Web Gateway, SWG. This tool scrutinizes both incoming and outgoing traffic, monitors web applications, and checks URLs. It also analyzes data for loss prevention, DLP, and sends alerts to monitoring systems like SIEM appliances. Additional tools include Cloud Access Security Broker, CASB. This set of tools or services sits between your on-premises infrastructure and the cloud provider. Think of it as a gatekeeper that makes sure your enterprise's security policies extend to your data in the cloud. Secure Access Service Edge, SASE. This is a unified cloud-delivered service model that combines multiple security services. It integrates technologies such as Secure Web Gateways, SWG, CASB, Zero Trust Architecture, ZTA, and WAN capabilities into a single solution. When working with cloud computing, several security issues can arise. Unauthorized access to data. Poor cloud security configurations can leave data exposed, leading to unauthorized access. Lack of visibility. Organizations often struggle with limited visibility into their cloud provider's security mechanisms, making it hard to verify if security controls are effective. Insecure APIs. While APIs are crucial for customizing cloud services, they can also be exploited by threat actors if they are not properly secured. Compliance regulations. Ensuring compliance is challenging in the cloud due to difficulties in tracking data location, access, and protection. System vulnerabilities. The complexity of cloud infrastructures and multiple third-party platforms can lead to increased system vulnerabilities. In traditional physical networks, the OSI 7-layer model is used to illustrate network functionality. However, with cloud computing, the OSI model becomes less applicable. This absence of a clear conceptual model can make it more challenging to select and manage security virtual devices. Although various cloud-based conceptual models are being proposed, none have gained widespread adoption. Securing cloud computing involves several key practices. Conducting audits. Regular independent examinations of cloud service controls to ensure security and compliance. Using regions and zones. Enhancing reliability and resiliency by duplicating processes across multiple geographical areas, known as high availability across zones. Secrets management. Implementing robust security and improved management for microservices-based architectures, maintaining flexibility and scalability without compromising security. Securing cloud computing also involves enforcing functional area mitigations, implementing specific security controls tailored to various functional areas as well as addressing hybrid cloud considerations, managing special security challenges unique to hybrid clouds, which span both public and private environments. Here are some best practices for managing hybrid clouds. Encrypt sensitive data. Ensure that all sensitive data and traffic between public and private clouds are encrypted, and inspect encrypted traffic to prevent potential breaches. Monitor and audit. Continuously monitor and audit cloud configurations. Utilize automation to manage these tasks efficiently, reducing the risk of human error. Run regular scans. Perform routine scans to identify and address vulnerabilities within your cloud infrastructure. Secure endpoints. Protect all endpoints to prevent unauthorized access and potential threats. Enforce zero-trust security. Implement a zero-trust security model, where no entity is trusted by default, regardless of its location within or outside the network. Knowledge check. Based on a common responsibility matrix, which of the following is a cloud service provider not responsible for? Devices, physical hosts, physical data centers, or physical network? Answer: devices. Cloud providers are not responsible for devices but leave this duty to users. Next up is virtualization, which lets us manage and present computer resources without worrying about their physical layout. Here's a quick overview. Host virtualization. This simulates an entire operating system environment. Virtual machine, VM. A VM is a software-based emulation of a computer, allowing multiple simulated systems to run on a single physical machine. Host system. This runs a VM monitor program, supporting multiple guest systems, the VMs, on the same hardware. Virtualization helps us consolidate multiple physical servers into virtual machines, VMs, that run on a single physical computer. Here's how it works. A hypervisor is the VM monitor program that manages the operating systems of VMs. Type 1 hypervisors run directly on the computer's hardware. It doesn't require an underlying operating system. Type 2 hypervisors run on top of the host operating system, functioning like a regular application. Containers are streamlined and hold only the essential OS components needed for a specific application, leading to reduced storage space and RAM requirements and faster startup times since the OS doesn't need to boot up. A popular use of virtualization is virtual desktop infrastructure, VDI, where user desktops run inside remote VMs on a server. Virtualization offers several benefits, including host availability. New virtual servers can be quickly created. Host elasticity. Resources can be scaled up or down as needed. Cost reduction. Fewer physical computers are required, lowering purchase and maintenance costs. Uninterrupted access. Virtualization supports live migration, allowing VMs to move between physical servers without affecting users. A software-defined network, SDN, enhances network flexibility by virtualizing parts of the physical network. It separates the control plane from the data plane, allowing for faster reconfiguration. When traffic needs to flow, the SDN controller first checks if it's allowed by the network policy. If approved, the controller calculates a route and updates each switch along the path to direct the traffic accordingly. A software-defined wide area network, SD-WAN, is a virtualized service that connects enterprise WAN networks across vast distances. It addresses the limitations of traditional WANs, like integrating connectivity between service providers and organizations, providing a more flexible and efficient solution. A software-defined visibility, SDV, framework enables network administrators to automate critical security functions. This includes dynamic responses to detected threat patterns, adjustments to traffic configurations for inline security tools, enhanced IT operations management functions. SDV streamlines network security and management by automating key processes. Virtualization has some pretty cool security perks. Safe testing. You can try out new security updates on a virtual machine first, so you're not risking your main systems. Snapshots. Save a virtual machine state at any point, so you can roll back if something goes wrong. Security testing. Test your security setup in a simulated environment before going live. Segregation. Keep different environments and apps separate to boost security. Virtualization also offers some handy security benefits. Sandboxing, where you can run suspicious programs in an isolated virtual machine to see what they do. If it's malware, it only affects the VM, keeping your main system safe. When dealing with security in virtualized environments, there can be concerns, however. Hypervisor security. Not all hypervisors come with strong enough security controls to fend off attackers. Old tools. Many security tools were designed for single physical servers and might not be effective in a virtualized setup. VM protection. Each VM needs protection from both outside threats and other VMs on the same physical server. VM escape. There's a risk that VMs might escape their isolated environment and interact with the host OS. Make sure you have solid protection against these risks to keep your virtual environment secure. Other areas of concern exist too, such as virtual machine sprawl, which happens when VMs multiply unchecked, leading to management headaches. To tackle this, you'll need virtual machine sprawl avoidance strategies. Virtual Machine Manager. Use a VM manager to keep track of and control your VMs. Harden hosts. Strengthen the security of your VM hosts with tools like Security Enhanced Linux, SE-Linux. Knowledge check. Which type of hypervisor runs directly on a computer's hardware? Type 1, Type 2, Type 3, or Type 4? Answer: Type 1. Type 1 hypervisors run directly on a computer's hardware instead of the underlying operating system. Type 1 hypervisors are sometimes called native or bare metal hypervisors. Alright, now it's time for a quick self-check. Rate your confidence in these module objectives from 1 to 5, where 5 means you feel totally confident and 1 means you're unsure. List and describe the different types of clouds and their locations, architectures, and models. Describe cloud security controls. Explain virtualization security. If you rated yourself less than a 4, you might want to revisit the module and check out the related exercises to solidify your understanding. Thank you for watching Module 11, Cloud and Virtualization Security. In this module, we explored the fundamentals of cloud and virtualization security, diving into the various cloud models, security controls, and the role of virtualization in managing resources effectively. We also discussed best practices for protecting your cloud environment and the challenges that come with it. I appreciate you taking the time to watch. If you enjoyed the video, please give it a thumbs up, hit that subscribe button, leave a comment, and share it with others. Your support is crucial for helping me bring more useful content your way. Thanks again, and see you in the next video.